this video will cover section 2.8, modeling using variation. The first variation we're going to cover is direct variation, which you can see the equation for it is y equals k times x. And that is similar to a linear function. So just write that down, please. And yes, you can think of the constant k similar as the slope of the linear function. But when we talk about variation, we're going to refer to it as the k is the constant of variation. We do not call it the slope. Now, how do we know that it is a direct variation? You guys could move your chair however you need to, okay? Or if you move around want to move around the classroom, that's fine too. So you will know because it will say the following: y varies directly as x, or it may say y is directly proportional to x. So that is how you will recognize that it is direct variation. And so what we have here is an example of direct variation. And that talks about the pressure in your ears depending on the depth of at which you are swimming. So you can see the graph here. And the graph, we have here the independent variable is not x, but they're using d to denote the independent variable, and that stands for the depth in the water, and the units are measured in feet. Now the dependent variable is not y, but p, and that stands for pressure, the pressure in the diver's ears, and the units are pounds per square inch. So as you can see, if the depth increases, right, as d increases, right, as d gets larger, what happens to the pressure? Does it increase or decrease? Increases, right? So you will answer like something like that. So here, for this particular one, they're already given us that constant of variation. So we don't need to really look for it. But if I was to ask you what will be the pressure at 100 feet, so of course you follow, right? And then you make your estimation there. I don't know. So you guys are 45? 43. Okay? All right. So now there are other problems where you actually have to find that constant of variation. So these are the steps that we're going to follow. Taking notes, everybody? Everybody needs to take notes. Everything I write on the board. So number one, write an equation that models the English statement. So we have here the problem says the volume of blood, and we're using the variable capital B to denote the volume of blood, in a person's body varies directly as body weight, and we're using W for that. So let's write an equation with that statement. So the volume of the blood varies directly, so K times the person's weight. And that's it. Now, number two, we have to find the constant of variation by using the given values. So the given values here are a person who weighs 160 pounds has approximately 5 quarts of blood. So if the weight blood is 5 quarts and the weight is 160 pounds, what will K be? So we substitute B with a 5. We substitute W with the 160. And then we solve the equation for K. So K is going to equal to 5 divided by 160. And we can leave that as a fraction, or we could reduce it to a decimal. Does anyone have a calculator available?
Mm-mm.
Okay, good. So K is going to give us 0.0, I think there's a 3, 5 over 160.
0.03125.
All right, thank you. And when you guys do this, try not to round too much, okay? You want to keep a few decimals, because if you round too much, then my mother will count it as wrong, okay? Here, so turn your chair, it's okay. So then if we move on to step 3, which is now substitute K, right? Substitute K into the equation. So our model here from number 1 used to be B equals KW. So now we know what K equals to from here. So we're going to turn that equation into 0.03125 W. All right. Number 4, it says use the equation to answer the problems question. And the problem usually comes at the end. Sometimes it might be at the beginning, but if you have a question when you only have one piece of information, then just keep reading and find the statement or the sentence that has 2. Like in this case, the 60 pounds and the 5 quarts of blood. So now the question is, how much blood would a person with a weight of 200 pounds will have? So B is the question. We use the model. B equals 0.03125 times 200. And could you do this one? Andrew? Oh, got it. 6.25.
6.25.
Quarts. And quarts of blood. All right, sample 5, we'll come back to it and, at the end. We have time. Okay, so now let's move on to, and actually, once we start chapter 3, which is about exponentials and logarithmics, we're going to do some problems that are multi-step, like this one, or 2-step, where you have to find that constant. That we don't call it constant of variation, we call it, what is it called? Growth constant or decaying constant. All right. Now here we have also direct variation, but with powers. And so if I told you the first one is kind of like a linear function, what would this remind you of? If you have an exponent other than at 1. Not exponential, not yet. What if I put a 2 here? What kind of function is that? Quadratic. Shape is a parabola. So n, if it could be a positive number, right? So then it could be like a polynomial. Because sometimes it will be to the square, to the 3rd power, so on. So similar. I'm sorry?
It could also be negative.
That's a great question. Yes, it can, but then it wouldn't be this kind. It will take us to the next one. Video.
Next one what?
The next type of variation, which will be, since you mentioned it, let's get to it. So if we have something like k, and then we have x to the power negative 1, it will be k over x to the power 1.
Oh,
yes. So for direct, the exponent will have to remain positive, so non-zero constant. Oh wait, that's for k. Let me see. It doesn't have any restriction, but yes, it will have to be positive. All right, so let's answer this problem. So we have number 1. We need to translate the statement to an equation. So we have the distance s that a body falls from rest varies directly as the square of time. So the first variable mentioned will be distance, and we're using s. Distance is actually your dependent. So the distance depends on the time. And so it says varies directly, so we know it's k times, and the square of time, so t to the power 2. So step number 2, we have to use the given information. And the given information here, we have that if a skydiver falls 64 feet in 2 seconds, so we change this to 64. We're still looking for t. We know time is 2, but we have to square it. So this is 64 is equal to 4k, right? 2 squared is 4. And the order doesn't matter because multiplication is commutative. So here to solve for k, it will be 64 divided by 4. So we get that k is 16. Thank you. So then we move on to step number 3, and step 3 tells us that actually step number 3 is where we substitute, right? So then we go back to our model, S equals k t squared. So now that we know what the value for k is, that is 4. So 16. 16 t squared. Okay. Now we move on to answer the question. Question says, how far would it be at 4.5 seconds? So that will be easy. Substitute t with 4.5, but don't forget that you have to square the 4.5. Does anyone have
20.25.
Say that again?
20.2.
But times 16 also?
Oh.
Okay.
Oh, come on.
Yes.
324.
Yeah, that sounds better. 324, and the units are?
Seconds?
Feet. Would be feet per second?
It will just, since it's worth this distance, it will only be feet. If it was speed, it will be feet per second. Or velocity. Okay. So let's move on. Now let's look at inverse variation, which, as you can recognize, it kind of looks like a rational function. The ones where the x is part of the denominator. And that's why it has that negative exponent there. And so the way we recognize it is by the words, for example, y varies inversely as x, or you could say y is inversely proportional to x. And once you hear that, you know that the second variable being mentioned will be in the denominator. So this question says, when you use a spray can and press the valve at the top, so like your hairspray or whatever you use, you decrease the pressure of the gas in the can. And the decrease in pressure causes the volume of the gas in the can to increase. So the contents of the bottle have to go somewhere. They're expanding. You're reducing the pressure, but they have to go somewhere. And so that's the reason why when you press that can, the contents come out. They have to be released. So because the gas needs more room than it is provided in the can, it expands in spray form through the small hole near the valve. In general, if the temperature is constant, and they have to clarify this because what happens if you increase the temperature? Would you affect the volume or the pressure of anything if you increase the temperature? Of course, right? You could even make things explode. Serene, let me see your screen. For what? Like turn it so I can see it. Thank you. You go like that. Thanks. There you go. So that's why they have to clarify that the temperature has to be constant. So now we have the statement here. If the pressure of the gas varies inversely as the volume of the container, so we have our equation right here, the pressure varies inversely as the volume, like that. So then what is the pressure of the gas sample in a container whose volume is 8 cubic inches? So now the volume is 8 cubic inches and the pressure is 12 pounds per square inch. Okay, so we're going to use that to find K. So in the formula, P equals K over B, we substitute the pressure with 12 and the volume with 8. So now to find K, the 8 is dividing to K, so if you move it across, it's going to multiply. 96. Okay, so then we move on to, in fact, number 3 is where we write the model correctly, so I'm going to write it here. Number 3 will be pressure is equal to 96 over volume. So then we want to answer the question now, so that would be part number 4. And that will be if the sample expands to a volume of 22 cubic inches, what is the pressure? So pressure is the question, and we have volume being 22 cubic inches. For 36? 36. And the units here, we're talking about pressure, so they are pounds per square inch. Okay, so examples 4 and 5, we'll take care of those on Wednesday, because I want to give you your full break. And the homework is not due this Wednesday, next Wednesday.